Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Mahatma Gandhi University, Rohtak. Right, so I will discuss the topic solution of the second order partial differential equation. Right, I have already told you about one or two cases related to the solution of this partial differential equation. So our another case will be case third, right? So let's see our case third here, right? So you can see here when right hand side fxy is equal to x to the power m into y to the power n. So our differential equation, second order differential equation is a d square plus b d d dash plus c d dash square of z is equal to fxy, right? This is our differential partial differential equation of the second order. So if our right hand side is x to the power m, y to the power n, then what we will do, we will do just write your f d d dash 1 upon f d d dash into x to the power n into y to the power n, and solve this by the binomial expansion. So here is an example here, so just let's see the example because we will better understand by our example. So del 2z upon del x2 plus 3 del 2z upon del x del y a plus 2 del 2z upon del y2 is equal to x plus y, right? So we can write it d square plus 3 dd dash because del z upon del x is your capital D, so del 2z upon del x2 will be your d square. Del z upon del x is your d, del z upon del y will be your d dash, and del 2z upon del y2 you can write d dash square of z is equal to x plus y. So for the complementary function, put d is equal to m and d dash is equal to 1 here. So m square plus 3m plus 2 is equal to 0. So you can write after factor these in this quadratic equation, we will get m plus 1, m plus 2 is equal to 0, or m1 is equal to minus 1, m2 is equal to minus 2. That means we are getting two roots and both of the roots are real and distinct here, right? Now if the roots are real and distinct, then our complementary function will be y1 f1 y plus m1x plus f2 y plus m2x, right? So this is our complementary function. Now for the particular integral, because right hand side is not equal to 0, so we will find our particular solution. So particular integral will be 1 upon f dd dash. So our f dd dash will be this one. You can see that this is our f dd dash. So just write here 1 upon d square plus 3dd dash plus 2d dash square. Right hand side is given x plus y here. So we will write x plus y. Now you can see that taking d square outside the denominator, when your right hand side is of the type x plus y by x to the power m, y to the power n types, whatever is given, then you will convert this denominator into 1 plus type. So to convert this denominator into 1 plus type, you will take d square as a common outside, then you will get 1 plus d 3d d dash upon d square plus 2d dash upon d square into x plus y. We have in each and every question, we will convert our denominator into 1 plus d type. So we have already converted this into 1 plus d type. So next another step is 1 upon d square, same as it is. There it is in denominator, so just write is in the numerator, so our power will be minus 1 here. So 1 plus 3d dash upon d plus 2d dash square upon d square to the power minus 1 into x plus y. Now apply binomial expansion. So our binomial expansion is, suppose we have x as a func variable, so 1 plus x to the power n is equal to 1 plus nx plus nn minus 1 upon 2 factorial into x square plus and so on. That means this is our binomial expansion. Now apply binomial expansion here. So we can see first that there is a power x to the power 1 here, y to the power 1 here. That means our total power is given 1. in the our right hand side. So we when we will expand our binomial expansion, so we will expand this only one term, because here power is 1. If power is 2, then binomial expansion will expand at 2 terms, right? So power 1, that means 1 plus nx, only 2 terms will be here, 1 plus nx, no need to further expand. That means no need to write third term. If power is 2, then we will write third term here, right? So you can see here that 1 upon d square, same as it is outside, 1 plus nx. So nx, so our x is, look at here, our x is 3d dash upon d plus 2d dash square upon d square. This is our, these two terms our x. So 1 plus nx, so 1 plus nx. So 1 n is given 1 minus 1. So 1 upon d square, 1 x here, n is equal to minus 1, x is equal to this one. So here x plus y power is 1. So expansion will expand only the 1 power, right? So 1 by d square, 1 plus nx into x plus y. So 1 minus 3d dash upon d plus 2d dash square upon d square of x plus y, right? Now 1 upon d square, multiply by x plus y inside the bracket. So x plus y into 1, x plus y, minus 3d dash upon d into x plus y, minus 2d dash square upon d square x plus y, right? Now 1 by d square x plus y, minus d dash means differentiating partially with respect to y, right? So d dash x plus d dash y, minus, here you can see power is 1. If power is 1 and differentiating is doing 2 times, then it will be 0 here, because higher term, these are the higher term and this is lower term. So if differentiation is higher term in higher term and variable is in lower term, then differentiation will be 0 here. Suppose you have you will do one time differentiation d dash with respect to y. D dash means with the differentiation with respect to y. So x differentiation will be 0 and y 1. Then we will, when you will apply again, that it will be gives 0, right? So x plus y minus 3 upon d dash x plus d dash y, x plus y minus 3 upon d, differentiating x with respect to y, so it will be 0. Differentiating y with respect to y, it will be 1. So 1 by d square x plus y minus 3 upon d into 1. Capital D means differentiation, I told you, and 1 by d means integration. So x plus y minus d means differentiation with respect to x. So 1 by d means integrating with respect to x. So one different x differentiation, dx differentiation, sorry, integration x here. Now y minus 2x. So here 1 upon d square minus 2d 2x. So that means integrating 2 times this step. So dx integration, 1 time x dx, second time x square by 2, x dx, x square by 2 dx, x cube by 3x. So this is a particular integral here, right? So complete solution will be complementary function plus particular integral. So this is your final answer here. That means if you have any function in x and y, then you will apply binomial expansion. And binomial expansion, then it means that you have to convert your denominator into 1 plus x type, right? That means if something is given, then you will take common, and there you will make a 1 in denominator. So 1 plus something, then put the denominator into numerator. So power will be minus 1, so your n will be minus 1, and x whatever is given there, right? And will apply binomial expansion till variable right hand side power is given, right? So next step, next non-homogeneous linear partial differential equation. So our equations are our partial differential equation, but that was homogeneous, right? So here non-homogeneous partial differential equation. Non-homogeneous means you can see there power 2 2 2, that means, and power here 1, order is 1 here, right? Here order is 2, the here order is 1. In our previous method, all are have the same powers, right? So the linear differential equation which are not homogeneous are called non-homogeneous linear partial differential equation. So there is an example here. You can see that order is 2, order is 2, order is 2, but order is 1, 1 here. So this is your non-homogeneous linear partial differential equation, right? Now FDD dash is equal to of Z is equal to F1 xy. That means if right hand side is equal to 0, that means your complementary function is the complete solution. But if right hand side does not equal to 0, that means you will calculate complementary function and also particular integral, right? So its solution is z is equal to cf plus pi. Complementary function, so there is method here. Let the non-homogeneous equation be d minus md dash minus a of z is equal to 0. That means if you are getting a solution, if you are having if you are having a differential function like d minus f md dash minus a of z is equal to 0, that means del z upon del x minus m del z upon del y minus az is equal to 0, right? So this is your linear differential equation, partial differential equation. So for the linear partial differential equation, we know that a rule like Lagrange method, right? Choose multipliers or something like that. So we will convert this into our auxiliary equation. So our auxiliary equation is dx upon p is equal to dy upon q is equal to dz upon r. So you can see here that this is your first order linear partial differential equation, and only one solution is there to solve the first order partial differential equation, only Lagrange equation. So dx upon p, that means dx upon 1, dy upon capital Q, that means minus m, dz upon capital R, that means az. So just taking first two terms, then you will get y plus mx is equal to c1. This is your first solution. And when you will take these two, then you will get dx is equal to dz upon az. So x is equal to 1 by a log z plus c2. So this is your second solution. And to combine both of the solutions, so your z is equal to e to the power ax phi y plus mx. And you can consider similarly the solution of d minus md dash minus a whole square of z is equal to e to the power ax phi 1 y plus mx plus e to the power x into e to the power ay phi 2 y plus mx. That means if roots are repeating, that means roots are real and same, then you will apply this one. So there is a proof here. If I write this solution directly, then you will not understand. You don't understand where it is coming from. So it is coming from here. That means you have a partial differential equation like this. Means like first order partial differential equation. Then we will apply Lagrange here, and we will write our solution right like this, right? So we no need to calculate all of these things, right? Then right, we can write our solution directly. That means z is equal to, if our partial differential equation is like that, so we can write z is equal to e to the power ax phi y plus mx. That means we have to learn this line, and if our roots are real and same, then we will apply this rule, right? Now there is an example here. So solve d plus d dash minus 2 d plus 4d dash minus 3 of z is equal to 0 here. So our equation can be written, we can see here that this is our first order, this is our first order. Multiplication is here, but no need to take any problems, right? So d plus d dash minus 2. So just look at here, d minus md dash minus a. So compare with this equation. So d minus md dash minus a. So and d minus md dash minus a into z is equal to 0. So we can see that m is equal to 1 here, minus 1 because d minus md dash. So your m will be minus 1, your m will be minus 4, and a is 2, a is 3 here. So our solution will be z is equal to e to the power ax phi 1 y minus m1x. So y plus m1x, m1 is your minus 1 here. So you can write minus 1 into x plus e to the power ax, that means e to the power 3x phi 2 y plus m2x, m2 is your minus 4. So m2 is your minus 4, just write minus 4 here. So this is our solution of this equation, right? Here d plus d dash, so you will convert it d minus, and there will be minus d dash here. There is a mistake here, d minus minus d dash here, so will be, your m will be minus 1 here, right? So we can write the solution directly from here to use this formula. Now there is another one example here. Solve r plus 2s plus t plus 2p plus 2q plus z is equal to 0. So we know that the all notation, P means del z upon del x, Q means del z upon del y, R means del 2z upon del x2, S means del 2z upon del x del y, T means del 2z upon del y2. So del 2z upon del x2, that means R, we can write d square, z s we can write 2 d dash, t d dash square plus 2d dash plus 1 of z is equal to 0. So to solve this equation, we can see that there is a factor here, and d square plus d dash square plus 2d dash. So a square plus b square plus 2ab. So we can write it d plus d dash whole square. And here 2 is common. So 2 into d plus d dash plus 1 of z is equal to 0. Again, we can see here that a square plus b square plus 2ab. So again, it is the whole square of a plus b. So we can write it d plus d dash plus 1 whole square is equal to of z is equal to 0, right? Now we can see that this equation and our above is a non-homogeneous linear equation, both are same, so we can compare. So we can write it d plus md dash plus a d minus md dash minus a whole square. So to convert this equation into d minus md dash minus a, so we can write plus 1 as minus 1, and here also plus 1 as minus 1 whole square of z is equal to 0. So m is your minus 1, a is your minus 1, right? And we are getting it into 2 times, that means our roots are real and same here. So e to the power ax, so e to the power minus x phi 1 y plus m1x plus x e to the power minus ax phi 2 y plus m2x, right? So this is our repeating root. So we will add one more solution here, right? So your particular integral and complete solution. This is your complete solution, right? Now in here right hand side all are 0. But if our right hand side is not 0, then we need to find our particular integral. So let's see how we will find our particular integral. So non-homogeneous partial differential equation particular solution. So case 1 here, 1 upon f dd dash e to the power ax plus by into phi xy of x and y. So e to the power ax plus by into phi xy. So our particular solution will be e to the power x plus by outside, and we will replace d by d plus a and d dash by d dash plus b into phi xy. That means if you have sorry, if you have any exponential function and also another function, then what will you do? You will just replace d by d plus a and d dash by d dash plus b here, coefficient of x and y, and your exponential function will be outside into phi x y, right? Now solve, there is an example here related to this case. D minus 3d dash minus 2 whole square of z is equal to 2 e to the power 2x sine y plus 3x. So our complementary function same as in the above solution. So complementary function, so CF will be just compare d minus md dash minus a whole square. So m is your 3 and a is your 2. 3 to the power 2x, so a to the power ax means 2x, pi 1 y plus 3x plus x e to the power 2y, phi 2y plus 3x. So this is your complementary function. Right now, pi is equal to 2 into e to the power 2x sine y plus 3. This is the right hand side. So 1 upon f d d dash. So 2 upon d minus d dash 3d dash minus 2 whole square, and right hand side e to the power 2x sine y plus 3x. So e to the power 2x here. So apply e to the power ax plus by rule here. So a is 2 and b is 0 because no y term here. That means coefficient of y will be 0 here. So 2 into e to the power 2x, that means d will be replaced by d plus 2 and d dash will be replaced by d plus 0. So d is replacing by d plus 2. So d plus 2 minus 3d dash minus 2 whole square. Here there is no 2 here, only 3d dash here, into sine y plus 3x. So our exponential work is done. So just write it outside. So 2 into e to the power 2x is outside, and d plus 2 minus 3d dash minus 2. So 2 will be cancelled out. Only we have 3 minus 3d dash whole square sine y plus 3x. Now 2 e to the power 2x, right? And 3 minus 3d dash. So ax sine ax plus by, that means our homogeneous partial differential solution. So apply here homogeneous partial differential solution. So when you put d square is equal to, that means when you apply a minus b whole square here, and you will put d square is equal to minus 3 square, and d dash square is equal to minus 1. So our solution will be 0. That means our case will be failed. So what we will do, we will just write here multiply by x, and differentiate fdd dash. So it will be 2d minus 3d dash sine y plus 3x, right? There are, I think, 2 or 3 steps missing here. And after that, 1 upon d 3 minus 3d dash. So just multiply by in numerator d plus 3d dash, and in denominator d plus 3d dash. Then again we will have d square minus 9 d dash square. So when you will put again a d square is equal to minus 3 square, and d dash is equal to minus 1 square. So it will again give 0. So our case will be failed. So what our next step will be, again multiply by x, and differentiate this again. So it will give uh, x square e to the power 2x, and d differentiation will be 1. So sine y plus 3x, right? So this is your solution here. That means if your exponential function and another function is given, so you will apply our first you will apply for the exponential, then you will apply for the next function, right? Now, another case 2 here, 1 upon f d square d dash square sine ax plus by. So we can see here d square is replacing by minus a square, d dash is replacing by minus ab, and d dash square is replacing by b minus b square, and sine ax plus by. So for the complementary solution of this function d plus 1, so d minus md dash plus 1, so m will be 0 here, and we can write it d minus md dash minus 1 a of z is equal to sine 2x plus y. So here m will be, m1 is 0 and m1 is minus, m2 is minus 1, a is minus 1 and a is 1 here. So just your complementary function is this one, e to the power ax phi 1 plus phi 1 y plus m1x plus e to the power ax phi 2 y plus m2x, right? Just write here all these values. This is your complementary function here. Now second step, particular integral. So write this equation as 1 upon f dt dash sine x plus 2y. So 1 upon, after multiplication you are getting this step. So sine rule is d square is equal to minus 1, because sine ax plus by, so a is your 1 and b is your 2. So d square is equal to minus a square. So d square is equal to minus 1. dt dash is equal to minus ab. So minus 1 into 2, 1 into 2 minus 2. So just write here. So minus 1 minus 2 plus d dash minus 1. After solving this, 1 upon d dash minus 4 sine x plus 2y. So again we need d square d dash square type situation. So to convert this into d dash square type, so just multiply opposite sign in the numerator and denominator. So d dash plus 4 upon d dash plus 4. Here we can see that a square minus b square rule will be applicable. Just apply a square minus b square. Now we are getting d dash square. So again put d dash square is equal to minus b square, and your b is 2. So minus 2 square minus 4. So just write here minus 4. And d dash into sine x plus 2y plus 4 sine 2x sine x plus 2y. So d dash means differentiating with respect to y. So minus 1 by 20 sine differentiation 2 cos x plus 2y. So 2y differentiation is 2 here, and 4 sine x plus 2y. It's simple. So our complete solution will be z is equal to cf plus pi, right? So our case third I will explain in our next session. And this question will be asked 7.5 or can be 15 marks. So just prepare your topic. Thank you.